A very good afternoon to one and all. Today, we will start our continuation topic, that is introduction of pharmaceutical organic chemistry. What is the basic concepts? What is heterocyclics? How the carbon has defined its role, as well as uh, how the structure is developed, how they are naming, how the IUPAC names, and with the continuation of the same topic, I will take a share of one good continuation presentation, other organic compounds with the functional attachment and how they are um, identified and how they are identify the naming, and on the page the naming structure, how you can write down the structures. So this is again from the Modern College of Pharmacy, Nigdi, Pune, and I am Dr. Pallavi Patil, assistant professor working as a working in a pharmaceutical chemistry department. So we will start the topic our. So now the other functional groups means if you are seeing the specific group attached of atom and forming a compound molecule, organic compound molecule. For example, halides. So definitely the chlorine have a very good power to attachment of the carbon, then bromide, fluorine, fluoro compound and iodo compound. These are the halides. Okay. So whenever the attachment of this to the carbon, they have a different to writing their name and identifications. We called as these are the halogen compound. So these are simple. If the F is attached, we say that the fluoromethyl or chloromethyl, bromomethane, iodomethane. It depends on the attachment of halides as a halogens. Now these are the functional groups attachment. You will see that the alcohol is OH attachment, hydroxyl, then organic acids, then aldehyde, ketone, ether, ester, amide, and amines. So these are the halides, again same thing. So we will see what you will the write down the name. Now this is a some simple structure of the methane. Okay. Now all is the single bond, and the chloro compound is attached to the chloro element is attached to the, we say that, a carbon. So how you write down the structure? Chloromethane, because a single bond. It is a saturated compound. And when the chloro is a 2 attachment of the carbon, so dichloromethane. If the one fluoro is attached, so fluoroethane, because there is a structure of ethane, a single compound but having single bond but having a 2 carbon. So the attachment of this individually carbon has a 4 attachment. One is a fluoro. Then the rest is the, we will see, a 2 fluoro. So 1, 2. At the different type of the carbon, that is 1, 1 difluoro. On the same carbon, there are the 2 attachment of the fluoro. So the ethane we will see. Now the somehow different if the chain is goes on with the carbon attachment. So definitely the structure is also write down in that way. So the 1 fluoro is identified. Then second carbon there is no fluoro. So the third carbon has a fluoro. So 1,3-difluoropropane. Okay. So as simple as the writing and the identification of structure, as well as on the base of name, you can draw the structure. So halide is as simple as. So we will see the next compound. It is the 2 fluoro. At the second position, fluoro is attached. Propane. This is all single bonded structure. Now, how you define the alcohol? Alcohol is attachment of the OH. And the example is the NER. You will say that the CH3, CH2, CH2, propanol. 1 propanol. The first carbon having attachment of the OH. So, we will write the propanol. So in this way, the simple structure of monohydroxy alcohol. Okay. So we will see the next one. Now the IUPAC we will see already in the last previous, that is the methane. E is dissolved from the entire this, and OL, methanol, ethanol, propanol, butanol, pentanol. Okay. So this is the structure of 2-propanol. Now we will see the acid. How we define the acid? Acid structure is the COOH. Okay. So this is the structure, and this is the formula, organic acid. And if you are writing any 3 carbon attaching, but the required is the COOH. There is a 2 oxygen, 1 hydrogen. So in this way, you can write the structure. Done. So for example, the aldehyde. The aldehyde having a molecular formula is a CHO. So this, the structure of this. If the propanol structure is having the aldehyde, so you have to attach a CHO. But the attachment is such a way that the C has 4 sides. So you have to, and the valency of the oxygens is we have to attach 2. And this hydrogen is a 1 bond. So the attachment in this way, and complete the structure with the general formula, functional groups, and classify the compound. Now these are the IUPAC name of, instead of the methan. Now in the simple way, AL, methanol, it's the formaldehyde. Ethanol is the acetaldehyde. The 2 carbon having a 1 carbon is the COH. The single carbon having a COH. So in this way, you can write the simple structures. This is a very good preserve biological samples. These are a 2D structure and this is a 3D structure. So the instead of the last E from the methane, you can write AL. Then alcohol get oxidized with the aldehyde. So you can write in such a way, oxidizing agent, and this R is as the same, and AOL get dissolved with the AL. This is the for alcohol oxidized with the aldehyde. So in simple way, you can write down the oxidations. In the same way, there are multiple reactions. Now we will see the ketonic structure. The ketonic structure is the CO is the attachment of a 2 alkyl group. So general formula is R1 and R. If you attach this CO anywhere for the 2 chain, 3 chain carbon, or 4 chain, 5 chain, so you will see that this is a 5. 1, 2, 3, 4, 5. So these are pentanone. The second position of the carbon having the attachment of the oxygen. So instead of the E, you can write an ON. Then the acetone is a simple structure of the acetone. Okay. Then the ether is having the same. If you have synthesized the ether with the 2 primary alcohol attaching with each other, so definitely R. So there are the different attachment of R and R1. You will see that the structure CH3, O, CH2, CH3. This is the ethyl, methyl, and the O is respective with the ether. So in this way, you can prepare the ether by using a primary alcohol in the general way. So in this way, the diethyl ether you can generate it with the 1 attachment of oxygen bridge, which is a condensed with a very good formula. condensing formula. Okay, so these are the condensing formula of the 2-methyl ether in this way. Okay, it's very simple and generated. Now, what is the ester? Ester also attachment of this COO with the different attachment of a 1R and second 1R. Ester is also written in such a way. There are the CH3, CH2, COO, CH2, CH3. So the both having the same attachment R1 and R2. So here is the diether ester. Now how do you see the propanate? Propanate means 1, 2, 3, 1, 2. Okay. So these are the propanate. Instead of the propane, you have to add O, A, and T, E, propanate. These are the condensed formula. You can write the condensed formula. In the exams, maybe they are expected to explain the condensed formula of this and explain the condensed formula of that. So you have to generate it in such a way. So these type of the structure. If in the first one, those who are starting with the structure understanding and having not a practice, they are definitely go for the numbering of the carbon and just write down in such a way. And then you have to find out the condensed formula. The methane, if you are drawing this one, with the releasing of one ammonia, definitely the amine gets synthesized by replacing of the methyl and addition of the one carbon, the synthesis of the ethanamine. What is the amide? Amide is the attachment of CON. These are the basic formula. So in this formula, the nitrogen can have a balance with the hydrogen. So these are the structure. And when we are putting this R is having a something, that is CH3, CH2 or anything that you can consider, and propanamide you have to mention. Then butamamide. In the examples of your first year B Pharm, there are very expected ki butamamide synthesize, identification as well as draw the structure. These are the very important questions for the amide to amine. Now, what is the substitution? So, if a single butane gets substituted with the bromine, so what the structure will be formed? Bromobutane. Bromobutane is the substitution of the bromine. These are the substitution reactions they are expected in the basic. If the structure gets condensed in this way, so the second bromide can be substituted for another H. This one, and it get to here. So simple reaction of the substitute. You can take any one here, ethane, propane, butane, and bromine chloride. Anything you can condense with the general formula. Then what is the additions of the certain type of additional by adding one or more groups with the attachment of double and triple bond. So it's very simple. If you are adding the saturated compound with the unsaturated compound, now we will see the small experimental part. If the fluorine atom is replaced by the hydrogen, so this is the fluorine gas, and you are just condensing this gas with the ethane. Ethane is having a double bond structure, unsaturated compound. With the certain experimental stretching this double bond, they can be release the double bond and then form a single bond. But they required certain condition to break down the bond. In this, it is having a free of one electron in each carbon. Each carbon having a one type of the electron which may be shared with the fluorine atom. The fluorine atom, when added by the side way, they break down this double bond and forming a single bond in between these, and the synthesis of one. This is the one, then 2 difluoroethane. This is an additional reaction of double and single bond by a substitution. So this is a very important. And a second one, the unsaturated synthesized saturated compound. So students, please focus this experiment. You can generate this by anything, that is iodo, bromo, chlorine, anything you can generate it very good way. Now what is a fermentation? If you are adding a good compound or a good long chain of the compound with the certain enzymes in the aerobic or anaerobic condition, the enzyme is act as a catalyst. It is automatically get fermented the compound, and the synthesis of with the structure of the glucose, a good chain structure, that is C6, we are synthesizing the ethanol and carbon dioxide. This experiment is useful for the fermentation. Molecule are broken down by enzymes in the natural way, in the natural types. So this is the very good examples for the fermentation. Now, what is the esterification? Now, these steps are also important. Esterification means what? There is the synthesis of ester. How? If the organic acid get combined form with the alcohol, the ester gets synthesized. And in this ester, the one molecule of the water is released. This is similar to neutralization of this reaction in the inorganic. Acid and base, salt and water. This type of the esterification with the formation of the slow reversible reaction. This is the reversible reaction. Okay. Now, what is the saponification? Saponification is also very simple. Saponification is the hydrolysis of fat by base. If you are taking a water, if in the presence of any fat, the organic compound of the ester get break down and formation of a certain a good compound of the carbon, that is a good chain, that is glycerol, we called as a one type of the alcohol with the organic acid. So soap get generated. So in this way, you have to generate the method for the sulfonification. Sulfonification is also break down the esters, is the type of the fatty acids that hydrolyze with the water. So these are the general reactions where we are explaining and express the saponification in a good way. If we are considering the triglyceride reacted with the fat, so the synthesis of the alcohol, and these are the sodium palmitate. Okay, this is a good chain of it. You can also called as a soap, because this is the structure of the soap actually, what we are using for the detergent and this type of the soaps. So these are the simple structures with the having a formulation of, we have to add it when saponification asked there, hydrolysis of an esters in the presence of hot base alkaline. Hot base is the important topic. Hot base is important as a, then polymers. What is the polymers? There are the different type of natural polymers. You can say starch, you can say protein, cellulose. These are the all type of the polymers. How the polymers get composed? They are the repetitive unit of the monomers. And when the monomers are linked to each other, they are forming this first monomer, the second monomer, then third monomer, and fourth monomer. We also see that they have individually linkage to each other. The individually monomer are linkages. These are the alpha 1,4 glycerosides linkages, glycoside linkages. The cellulose is made up of the repetitive unit of sugar. Protein is made up of the repetitive unit of the amino acids. Starch is the repetitive unit of the sugars. So these are the, now the synthesis, these are the examples how these are, when they a huge chain of the carbon get linkages with each other with the good monomers, they are forming a thick type of compounds with the using certain chemical structures, chemical mechanisms, and chemical condition. They are forming a certain materials. We called as polyesters, nylon, rayon, this type of polyethylene, this type of, we will see. The condensation means if the two monomers are get combined with each other, they will form the monomers. It's very simple. One hydrogen molecules get attached and releasing of hydrogen. Simple way. These are the polymers. Now, how the polymer get condensed with each other? This way. Then releasing one hydrogen water molecule. Then monomer is there, ethylene, ethylene, the formation of the different type of the polyethyls. So these are the how the balance reaction we will see. This is very important. If you are not able to understand how the balancing the reaction, number of atoms on the left side and number of atoms on the right side. So you will see these are the one of the good examples. This is ethane, chlorine. The left side is the C2 and H6 plus C2. Now this side. Now the right side, what we are seeing? This is the 1. So is there any missing? You feel that? Is there any missing? Yes. So what is the missing? This is the missing of one chlorine and one hydrogen. And how the missing product get formed? The HCl. This is a substitution because the hydrogen atom of ethane is replaced by chlorine. So this is a very small and sweet reaction by the examples of the balancing reactions. Now these are the examples how the condensation of polarization. We see the biscuits, fermentations. Vinegar is the best example. That is when the apples get extremely fermented, forming a vinegar. Then soapinification, the soap is the best. Combustions is the routine example, that is candles and this. Then additional polymerizations is this. So now I'm taking this end of the sessions. So I have taken all the pharmaceutical organic chemistry 11 to 12 to first year B Pharm. We have all seen that the chemistry, classification, organic chemistry compound, carbon chemistry, hydrogen chemistry, oxygen chemistry, how the structure get developed, how their heterocyclic compound attach, aliphatic chain, aromatic chain, classification, type of organic compounds, and their structural and define IUPAC name. And on the base of the structure, you can write down the IUPAC name, and on the IUPAC name, you can draw the structures. With that, a different type of functional group additions and how the changes in their IUPAC name with respect to the attachment of the functional group. So in this sessions, I'm just taking a leave now. Before that, I just want to say thank you very much for giving me a valuable time and spending your quality time and listening my lectures. If you have any queries regarding this topic, you can add your Dropbox in the chat box questions. Definitely, I will go through it and reply as soon as possible, as well as whenever this video I would like to upload, or soon I will upload this to the YouTube. And if in the subscription box, I will definitely link for that and add my email address. You can mail me your questions, or you can ask me any type of the questions regarding this topic. So I will definitely reply you soon. Thank you very much.